Hey everyone, so this week is functions. What the heck? Ugh, sorry. And this is actually going to be hopefully a pretty straightforward and simple week. A function is really, it's not much different from an equation. It's just something that's used more in real life, right? So a function is a relation between two variables. So that for each value of x, or well, it could be any variable, but we're going to stick mainly with x and y, there is exactly one value of the other. So typically it would be y, x and y. Okay, so use more in like everyday real life examples. Really, functions are just applied algebra. That's, like when you're talking about formulas for drug dosage, as like a nurse or a doctor or whatever, things like that, they're using functions because you're going to have a different output and a different input and a different output for every single person, right? For every patient, right? Things like that. So that's what a function really is. It's just applied algebra. They're typically written like this. And then you'll have like an equation, it might be different each time. You can also think of it instead of f of x. That's how it says f of x is equal to 2x plus 3, or you might see it as 2x, y equals 2x plus 3. Oops, sorry. Okay, so we're just saying that, and we're getting into graphing. This is kind of our lead-in into graphing. So next week, you're going to be doing a whole lot of equations like this. Right, now we've got two variables. We've been solving equations with just x, right? It would be a number equals 2x plus 3. We're solving for x. Now we've got two variables in here, but this just means that you have a whole range of correct answers. Okay, you have lots of different right answers. Okay, so, keeps doing that. I'm trying to scroll. Right, so what f of x is really saying is what is the value of the function given? Like, so for example, above it's 2x plus 3 in terms of x. Okay, and whatever x is. So there's actually lots of right answers because it depends on whatever your x is. So if I rewrite this, so let's say, what if x equals 2? Okay, then I'm going to say, what is f of 2? F of 2 is 2 times 2. All I'm doing is substituting the 2 into x. And the function when x is 2 is equal to, and then we just solve this side. It's 7. All right, so this is our function. I was given a value for x, I plugged it in, and so therefore the value of the function when x equals 2 is 7. Right, and we can do this, for any value of x. So what's the value of the function when x equals 6? That's what this is saying, right? Find the value of the function when x equals 6. Okay, so again, I'm going to plug it in. Twelve plus 3. So f of 6 is equal to 15. Right, how about if x equals -1? So f of -1 is equal to 2 times -1 plus 3. So really it's just substitution. This is essentially what we did in the second week of the quarter. Just writing it in a different form, you know, kind of making something that was simple into something more complicated, right? Oops, sorry, I didn't finish it. So that equals 1, right? And your function might change. So right now we're working with this function of f of x is equal to 2x plus 3, right? But maybe you have a different one. Sometimes they use different letters. Sometimes they'll say g of x. It still means the same thing. It's mainly like if you have a lot of functions that you're working with in relation to each other. So maybe you have an f of x and a g of x and an h of x. And so they sometimes will use different letters. It's still the same exact concept, right? Don't know, maybe you can just make it up. -3x minus 2. Okay, so let's just say that's our function. So now they want me to solve for maybe g of -1. Okay, so that just means I'm going to plug -1 into x, right? You have to, sometimes they even use different variables. So they might say g of z is equal to -3z minus 2, right? Same concept, it's just now they decided to use the letter z for their variable, right? So it's all the same thing, it's just changing letters. Because the letters really don't matter as long as they're consistent. 3, right? -3 times -1 is positive 3 minus 2, so therefore g of -1 is equal to 1. Right, maybe, what about g of 3? So -3 times 3 minus 2. So g of 3 is equal to -11. Right, so hopefully that's pretty straightforward. Oops.